Hey there, pre-cal students. This is a video about a word problem involving vectors. This is almost the same as your extra credit assignment this week. So if you want to attempt it, you'll definitely want to watch this video because the problem is a little bit challenging. Just be warned, you won't be able to just watch this video and completely understand what this problem is all about. So what you need to do is open up the Stitz-Zeager Volume 4 PDF and go to page 1062. So pause the video, go to page 1062, read over that word problem, and then start this video again. What I've done is I've drawn a diagram for that problem where you had a 50-pound weight that was supported by two wires. So a 50-pound weight exerts a force of 50 pounds straight down. That's represented by the vector 0, negative 50. It's negative 50 because, well, gravity goes down. So the wires have to support that, and there's tension on the wires in the direction that you see in my diagram. So what I've done is I'm not using the same notation that they're using in Stitz-Zeager. Their notation is a little bit better, to be honest. It's a bit more mathematically precise, but it is a little bit difficult to read if you're not used to reading that sort of thing. So I have used a little bit a simpler notation. So this wire on the left has components x and y. So component form of the vector is xy. And I'm using just the single letter z for the magnitude of the vector. So z is not a vector here, z is the length of this vector. And the same thing for the wire on the right. I'm calling AB its component form, and then C, again, C is not a vector, C is the length of this vector. So anyway, what we have to do is, well, find all the stuff. We have to find X, Y, A, B, find Z and C. So just think about that for a second, how difficult this problem seems on its surface. I mean, there's a ton of variables here. It's kind of a complicated situation. The wires that are holding this weight up are at two different angles. So it seems like this problem would just be almost impossible to solve. However, that's kind of the reason why vectors are so useful in mathematics and physics. This problem is actually relatively simple. We just make one observation, and that is this weight is not moving. It's supported in the air by the wires. So what that means is the net force on this weight is 0. If there was a force on the weight, it would be accelerating. So we know the net force is 0, and that's the entire logic of this problem. If you add this vector, the tension on this wire, and you add this vector, the tension on the other wire, and you add this vector, the weight, the sum has to be 0. So the logic of this entire problem is noting that vector xy plus vector AB plus the vector 0, negative 50 gives you 0. That's our avenue for attack on this problem. Of course, there's quite a bit more to be said. This equation, this vector equation, looks like it has 4 variables in it. Well, that would not be very fun. So let's go back to the diagram and use some other things that we know about vectors. In particular, you want to use the information from my previous video about component form. If you have not watched that, you will need to. So what we can do, if you want to simplify component form a little bit, is you say, well, the adjacent side x, that is, if you turn your pen on, this adjacent side is the magnitude of the vector times the cosine of the angle. Now, if you watch that video, you'll know that this is not quite correct. I can see in the diagram that x is negative, but the cosine of 30 degrees is a positive number. Z is positive because the magnitude of a vector is always positive, so I need to manually go put in the minus sign. In the same way, y, this is the opposite side from the angle. Okay, y is the magnitude times the sine of the angle. Now, 30 degrees is a nice unit circle angle, so we know what the sine of 30 degrees is, and we know what the we know what the cosine of 30 degrees is, so we can simplify this expression a little bit. If I remember correctly, the cosine of 30 degrees is the square root of 3 over 2. I have this negative, so that means the adjacent side is negative z square root 3 over 2. The sine of 30 degrees is a half, so y is simply z over 2. All right, we need to do exactly the same thing with the tension on the wire to the right. So let's see, the adjacent side. Okay, well, adjacent side is the cosine of the angle times the magnitude of the vector, which is c in this case. And the cosine of 60 degrees is a half, so a is c over 2. No need for a negative because a is going to the right. A should be a positive number, and it is. Let's see, in the same way, this opposite side is the magnitude of the vector times the sine of the angle, so times the sine of 60. The sine of 60 is square root 3 over 2. So let's see, that means b is c square root 3 over 2. All right. Now if we go back to our algebra, we can simplify this vector equation quite a lot. So let's see, the vector xy, that is negative z square root 3 over 2, comma, z over 2, plus the vector AB. All right, so the vector AB, A is c over 2, and then c square root 3 over 2. Plus the vector 0, negative 50. So if I add these three vectors together, I get 0. Now we know how to add vectors if they're in component form. You just add the components together. So I have negative z root 3 over 2 plus c over 2 plus 0. So let's see, that's negative z square root 3 over 2 plus c over 2. So that's the first component plus 0. I don't need to add a plus 0. That doesn't do anything. And now I add the second components together. So that's z over 2 plus c square root 3 over 2 minus 50. So let's see, that's z over 2 plus c square root 3 over 2 minus 50 equals, now I've actually used some bad notation here. The right side of this equation is not really 0, at least it's not the number 0. The right side of this equation is the 0 vector. So really the right side of that equation is the vector 0, 0. Now, as complicated as this looks, this is really connected to something that you learned in Algebra 1. There are two equations here. You have, let me switch colors and I'll highlight it for you. The first component of this vector equals the first component of this vector. So you have negative z root 3 over 2 plus c over 2 equals 0. That's just an equation with two variables in it. The variables are z and c. And then you have the second component of this vector and the second component of this vector. So that's just another equation. Z over 2 plus c square root 3 over 2 minus 50 equals 0. So we have two equations and two variables. Well, That's algebra 1. That's a system of equations. So all you do from this point on, no matter how many steps it takes, what you're doing at this point is you're solving a system of equations. So I'll take this first component. I'm going to switch the order just because I don't like this starting negative sign. So I'm going to write c over 2 minus z square root 3 over 2 equals 0. That's one of our equations. And then the other equation is z over 2 plus c square root 3 over 2 minus 50 equals 0. Two equations, two variables. So this is just a system of two linear equations with two variables. I think it makes more sense to most likely solve this equation using the substitution method. This equation on the left, it's pretty easy to get c by itself. So let's see, c over 2 equals z square root 3 over 2. And if you multiply by 2 on both sides, you get c equals z root 3. So we're going to take c and we're going to replace it with z root 3. So we're going to go over to this second equation and we're going to replace the c with the z root 3. All right, so we have z over 2 plus z root 3. So c turned into z root 3. We have another copy of root 3 over 2. And I'm going to go ahead and move the 50 to the other side. I think we'll have to do that anyway. All right, so let's see. We have z over 2 plus the square root of 3 times the square root of 3 is 3. So we have z over 2 plus 3z over 2 is 50. And let's see, z over 2 plus 3z over 2, that's 4z over 2. 4z over 2 is 2z equals 50. So z is 25. So what that means is you have 25 pounds of force in this wire on the left-hand side. Now that I know that z is 25, I can go plug that in and find c. So c is 25 times the square root of 3. So there you go. That's the tension in the wires. If you wanted to at this point, you could find x, y, a, and b. This question did not ask us to do that, so I'm not going to do that. All you would do is plug in the numbers. So you could plug in z equals 25, plug in c equals 25 root 3, and you could find the component forms of these vectors. That's not what you were asked to do. You were just asked to find the tension in the wires, which is what we've done. Now the textbook does ask one kind of interesting question. The weight was 50 pounds here, but if you add the tension in the two wires, 25 plus 25 square root of 3, you get something more than 50. That number is more than 50. So think about why, and that's a physics question, so go ask Ms. Adair for the answer, but it's worth thinking about. It's kind of an interesting question. Anyway, I know this is an involved problem. That's why I made it an extra credit assignment this week. If you feel like tackling this question, it's definitely worthwhile. Just look at the assignment on my All Saints, and you can see what I ask you to do if you want to try to tackle it. Anyway, I hope this helped. It does show you how powerful vectors can be. Just let me know if you need anything else. See you next time.